And welcome back to Cajun Coding, Code Friends and Code Family. This is St. Raz again, and we are on to the next section of learning Python 3 in the SoloLearn learning app, running on the Mimu emulator on my laptop. And of course, you can use an Android smartphone or an iPhone to get your fill from SoloLearn. If you want to use a laptop, both Mimu and SoloLearn are completely free of charge, even though you can upgrade to a subscription or a premium version. And we're getting into object-oriented programming. The first order of business on learning object-oriented programming is classes. We have previously looked at two paradigms of programming: imperative, using statements, loops, functions as subroutines, and functional, using pure functions, higher order functions, and recursion. Another very popular paradigm is object-oriented programming, sometimes abbreviated to OOP. Objects are created using classes, which are actually the focal point of OOP. The class describes what the object will be, but is separate from the object itself. In other words, a class can be described as an object's blueprint, description, or definition. You can use the same class as a blueprint for creating multiple different objects. Classes are created using the keyword class and an indented block which contains class methods, which are functions. Below is an example of a simple class and its objects. So we've got here class cat, and then define init self color legs, and colon self.color color, and self.legs legs. And I would presume that this is an abbreviation for initiate or instantiate, and then self color legs. So we're calling the color method on the self object and assigning to it a color, and then the same thing with self.legs, where we're taking these arguments and applying those to the instance of an object when it's created. So for example, here we've got Felix, and then we're going to call the cat class and pass in Ginger and 4. So Felix is the variable we're using to identify the cat. So the name of the cat would be Felix. He's ginger colored cat with 4 legs. Rover, which is an interesting name for a cat, which is dog colored with 4 legs. And Stumpy tragically has 3 legs and is a cat that is brown. The code defines a class named cat, which has 2 attributes, color and legs. Then the class is used to create 3 separate objects of the class. Sometimes the specific object is called an instance of a class. And tab continue to learn more. What type of object is a method? A method is a function. Think of objects and classes as being nouns, and methods are more like verbs. When you call a function, it's going to do something, whereas an instance of a class represents an instance of an object type, of a class type. And the init method is the most important method in a class. This is called when an instance, an object of the class, is created using the class name as a function. All methods must have self as their first parameter, although it isn't explicitly passed. Python adds the self argument to the list for you. You do not need to include it when you call the methods. Within a method definition, self refers to the instance calling the method. Instances of a class have attributes which are pieces of data associated with them. In this example, cat instances have attributes color and legs. These can be accessed by putting a dot and the attribute name after an instance. In an init method, self.attribute can therefore be used to set the initial value of an instance's attributes. For example, we have class cat, define init self color legs self.color and assign that color, self.legs assign legs. For example, Felix assigned, we call the cat class and pass in Ginger. And for print Felix color, which is when we're calling the specific instance, the object instance of the class, and then we use the dot operator, it's going to access that attribute, which in this case is the color, which for Felix is Ginger. In the example above, the init method takes two arguments and assigns them to the object's attributes. The init method is called the class constructor, which constructors are used in other languages as well. Python's not the only object-oriented language. Java is famously object-oriented, and they use the terminology constructor there as well. Fill in the blanks to create a class and its constructor, taking one argument and assigning it to the name attribute, then create an object of the class. So we've got class student, define, is it 2 underscores? I think it's 2 underscores in the beginning and the end. So self dot name test student Bob. Okay. The keyword init is preceded and followed by 2 underscores. Classes can have other methods defined to add functionality to them. And remember that all methods must have self as their first parameter. These methods are accessed using the same dot syntax as attributes. So here, let me see. Pretty familiar with this stuff. Now we're going to define bark. Let's see, self print woof. So the bark method would just print out woof. So we've got Fido dog, Fido brown, print Fido name, and then we're going to invoke the Fido object, which is an instance of the dog class, and then .bark is going to call the bark method, which will print out woof. Classes can also have class attributes created by assigning variables within the body of the class. These can be accessed either from instances of the class or the class itself. And see, class dog legs for define init self name color, self.name, self.color. And then we've got Fido, which is an instance of the dog. His name is going to be Fido, color brown, print Fido legs, print dog legs. What this is doing is we're going to invoke Fido and query how many legs he has. Well, we didn't say how many legs he had when we defined Fido, but we defaulted dog legs to 4 when we defined the dog class. So all dogs that have 4 legs by default. And it says here class attributes are shared by all instances of the class. Fill in the blanks to create a class with a method. Say hi. So class student, I think we need a colon here. Let me see, say hi, method say hi. So this is going to be our method. We're going to define that. We're going to put here, see, say hi. oh, it's going to take a name. So it's going to take the name of the object we're putting in. There we go. That's what that is. So hi from, and then it gives self, whatever the self is, and then of course it's going to invoke the dot operator, the name method, to display that. Trying to access an attribute of an instance that isn't defined causes an attribute error. This also applies when you call an undefined method. So class rectangle, define init self width height, self width and self height, and then rectangle 7 8 print rect color. Well, we don't have a color attribute, so it throws the error, attribute error. Rectangle object has no attribute color. What error is caused by trying to access unknown attributes? That would be attribute error. No, come on, how do I get out of this? I'm going to open an ad. Okay, there we go. So we're finished with the introduction to classes there. Inheritance. Inheritance provides a way to share functionality between classes. Imagine several classes, cat, dog, rabbit, and so on. Although they may differ in some ways, only dog might have the method bark. They are likely to be similar in others, all having the attributes color and name. This similarity can be expressed by making them all inherit from a superclass animal, which contains the shared functionality. To inherit a class from another class, put the superclass name in parentheses after the class name. So here we have, say, class animal, and we define init self name color, self.name equals name, self.color equals color, which will be passed in as arguments when the constructor is called. Now we have class cat animal in parentheses. That's going to inherit all of the attributes of the animal class, and then we define per and pass in self. That's the method per, which is going to print per to the screen, and then we have the class dog, also a subclass of the superclass animal, and then we define the method bark, which prints wolf to the screen. And then we create Fido, the class dog, pass in Fido in brown as the name and color, and then we can print philo.color, which results in brown, and then call the bark method on the Fido object, which prints out wolf. Note that we do not define color in cat or in dog. The color attribute is, and the name attribute as well, those are inherited from the animal superclass. What piece of code shows a new class spam inheriting from egg? So we have class spam and then in parentheses egg. A class that inherits from another class is called a subclass. A class that is inherited from is called a superclass. And this is the same terminology you'd have in a set, subset, superset if you're discussing classifications in a mathematics context. So if a class inherits from another with the same attributes or methods, it overrides them. So say we have the class wolf, and we're defining our attributes and methods and such. The class dog inherits from wolf. Now when we call bark from a wolf, it prints grr. But we define bark in the subclass dog, which inherits from wolf, it prints wolf, woof. So we have husky. We're going to instantiate husky as a dog, name Max, color gray. When husky barks, he was created as a dog, so it's going to print wolf. Probably because wolves don't bark. Dogs bark, wolves don't. Because dogs are kind of sissified, immature wolves. Wolf cubs bark, adult wolves don't bark. They'll growl or they'll howl, but they don't bark, which is thought to be an atavism, a trait where juvenile behaviors like barking are exhibited in adults, because dogs kind of don't, or kind of like wolves that don't grow up. What is the result of this code? Class A, define method self, which prints 1. Class B inherits from class A, define method self, print 2. So now we have B. Doesn't look like it's instantiating it. So okay, I'm sorry. This is an instance. Where's our instance? See method. I think I would print 2. Yeah. Yep. I don't see where it's instantiating it though. The classes are defined, but I don't see them instantiating an object. Inheritance can also be indirect. One class can inherit from another, and that class can inherit from a third class. So if we have class A, we define that. Class B inherits from A. Class C inherits from B, which inherits from A. So if we have C, here's the instantiation. So if we have small c assigned to small c, and we call the constructor for C, the class, with the large C, C dot method. We don't have, let me see, method, C method, B method, A method. Well, a C method would print out, why does it print out A method? Oh, this is defined as third method. So if we just do method, we don't have just method. It inherits from B. Well, that's another method. That's not just method. We go all the way up to A, a superclass 2 echelons above in the hierarchy. It has method, just method. So since it's just method, it outputs A method. Another method, this is not another method, this is another method, which prints out B method. And then C third method is right here, which is only available to class C. Circular inheritance is not possible. Oh, that sounds like a mess. Where you have like A would inherit from a subclass? No, that's not going to work. I should say it doesn't work in Python. I don't know how you would get something like that to work. Not so confident I'm going to say that it couldn't ever possibly work, but I don't see how it could. what is the result of this code? Class A, let's see, well, def A, print 1, class B inherits from A, def A self, print 2, class C inherits from B, which inherits from A, def C self, print 3. Okay, so we're going to instantiate C as a object of class type C, and then we're going to call A on C. And what's A? A is right here, so it's going to print 2. Okay, now you see here in class A, there's A, so it prints 1. Okay, well, we also define it in B, and when a method is defined in a subclass, that overrides that same method if it was also defined in a superclass. So what we're doing is, in our subclasses, we are adding behaviors that were not defined in the superclass, but we can also override behaviors that were defined in the superclass. The function super is a useful inheritance-related function that refers to the parent class. It can be used to find the method with a certain name in an object's superclass. Super. So we've got our superclass, we've got our subclass B, which inherits from A, and now we're going to call the function super on spam, which is defined here, but we also have spam here. So when we call spam using the super function, it should print 1. Results. Okay, here it prints 2 there, but then when we use the super function, it prints 1. So if you need to skip up to the behavior of a superclass, you can do so. And here it's explained, super.spam calls the spam method of the superclass. What is the superclass of a class? Let me see, the class that it inherits from. This here says the first class that it inherits from. Well, what do you mean by the first? Are they referring to one echelon up in the hierarchy, or is it referring to the very top superclass in the entire hierarchy? Because if they're talking about the one echelon above, this would actually be the correct answer. But I think I'm going to go with this one, because the superclass, if you're just talking about one superclass of a class, it seems like you would be referring to the one that it directly inherits from, not the one that the one it inherits from. So let's see if I'm right about that. Yeah, they must agree with my reasoning there. The subclass of a subclass. If class A, let's say if class C inherits from class B, and class B inherits from class A, then C is a subclass of a subclass of A. So you could say that C is a subclass of A, but I think it would be more accurate to say that C is a subclass of B, even though B is a subclass of A. So I'm sure I've never heard of magic methods before. Magic methods are special methods which have double underscores at the beginning and the end of their names. They are also known as dunders. So far, the only one we have encountered is init, but there are several others. They are used to create functionality that can't be represented as a normal method. One common use of them is operator overloading. This means defining operators for custom classes that allow operators such as plus and times to be used on them. An example magic method is add for plus. Okay, so say class vector 2D, define init self x y, self.x equals x, self.y equals y. This is all pretty familiar. Now we're going to define add, which is, we're going to be using it for operator overloading. So add is going to be a magic method. Self other, return vector 2D self.x plus other.x, self.y plus other.y. So this other, we're going to be passing in another object which has x and y attributes. So first equals vector 2D, and then passing in 5 and 7 in this case, and then second vector 2D passing in 3 and 9. The result will equal first plus second, and then the print result.x, result.y, and it's going to come up with 8 and 16. And as you can see, that's added. The x's are 5 and 3, which is 8, and 16 is 7 plus 9. The add method allows for the definition of a custom behavior for the plus operator in our class. As you can see, it adds the corresponding attributes of the objects and returns a new object containing the result. Once it's defined, we can add two objects of the class together. What is the magic method for creating an instance? That would be underscore underscore init underscore underscore. More magic methods for common operators: sub for subtraction, mul for multiplication, trueDiv for division, floorDiv for floor division, mod for modulo, pow for power exponents, and for and, XOR for the caret symbol, or for pipe. And we're probably going to get into OR and XOR later, but that's an interesting topic. The expression x plus y is translated into x dot add and pass into y. However, if x hasn't implemented add, the x and y are of different types, then y dot radd x is called. They're equivalent R methods for all magic methods just mentioned. And here is the code explaining that, or as an example of that rather. So we've got init self cont, self.cont equals cont, trueDiv self other, and then line, this is going to show the equal sign, and then the length other dot cont, and then this is a new line, join self cont line other cont. Okay, and spam be special string spam hello special string hello world, print spam divide hello. Let me see, trueDiv, so we've got spam. This is going to repeat. The reason we have this line here is because we're instructing the line to repeat the equal character times the length of other.cont, which is hello world, which is why it's the same length as hello world there. And then the \n is the escape. The escape in is for new line, which is why these are on separate lines. So In the example above, we defined the division operation for our class special string. What is A XOR B evaluated as if A doesn't implement any magic methods? So it would be, see, B should be this one right here. If it doesn't have any magic methods. No, that's not it. I think it would be the R, because the R is what we use, is the alternate. The R variant is what we use if we haven't implemented magic methods. That's why that's like that. I'm not sure if we're going to get to XOR soon. XOR is the exclusive OR, and we may go over this later as well. I haven't been through the course, so I don't know what's coming up. But OR has two variants. It's the normal OR, and then there's the exclusive OR. And inclusive OR means that if A or B, if either of those is true, then it resolves to true. But if both of them are true, it's still true. The exclusive OR, or XOR, which is sometimes the little chevron that's pointing up, is called a caret. C-A-R-E-T, not the vegetable, C-A-R-R-O-T. The caret is often used in multiple programming languages. It's used to indicate XOR. XOR is the exclusive OR, which means that if A is true or if B is true, then the statement resolves, the comparison resolves to true. However, if A and B are both true, it resolves to false. And of course, if neither is true, it's also false. But XOR is exclusive OR. So, and moving along, magic methods. Python also provides magic methods for comparisons. And we've got less than, LT, less than or equal to, not equal to, which is the bang equals, greater than, and greater than or equal to. If not equal is not implemented, it returns the opposite of equal to. There are no other relationships between the other operators. Let me see. So we've got class special string, and we've got the definition for the classes in here. So if we do spam greater than eggs, and so this is going to output. This is all custom behavior based on what we desire for the output. So you can define any custom behavior for the overloaded operators. What is LE a magic method for? It would be less than or equal to. So less than or equal to right here. There are several magic methods for making classes act like containers. LEN for length, get, indexing, get item for indexing, set item for assigning to indexed values, del item, so delete item, iter for iteration over objects, for example in for loops, contains for in. And of course the reason we have these magic methods is because we need to often we'll have objects that are of a custom class. They're a custom data type. Another thing about classes is that a class of a given definition is a different data type than an integer, say an integer or a string or a float. And because of that, those other operators are not going to work, or those other methods are not going to work because it's the wrong data type. So we need to use these to define how we want those to behave in that instance. So print length vague list b6. Where's vague list? Let me see. Self cont equals cont. So we've got 1, 2, 3. That's 5. So why is it showing us 6 here? And length vague list, that's 7. Print vague list 2 D. I see. It's because we have some of this behavior in here that's changing the list from what it was previously. Okay. We have overridden the length function for the class vague list to return a random number. The indexing function also returns a random item in a range from the list based on the expression. So these are not these behaviors are not, this is custom behavior that we're defining from these methods that normally would behave as we've seen in earlier examples, but now this custom behavior involves them returning some randomized values, which is why it's returning these numbers. And these would be, if I'm not mistaken, these would be different each time you run it, likely, because of the randomization. So we run this. Kind of taking a while. C is 34 BC. C 27 BB. Of course, when you randomize things, you can get the same result, but you're not likely to get the same result 71 CD. So this is producing random data, basically. Which magic method call is made by x, y equals z. So what we're doing is we're assigning z to x index y. So we're setting an item. Now we don't have the underscores here, so that's not a magic method. And we've got the assignment operator, so it's going to be changing an item, not getting an item. So here we've got the underscores for a magic method, and then obviously set would be associated with the assignment operator. So there we go. And we've got object lifecycle here, and I think this is going to be the last one for this video before closing the lesson out. So object lifecycle. The lifecycle of an object is made up of its creation, manipulation, and destruction. The first stage in the lifecycle of an object is the definition of the class to which it belongs. We have to define the class to describe what the object is like in terms of its attributes and methods. Then the next stage is instantiation of an instance, when init is called. Memory is allocated to store the instance. Just before this occurs, the new method of the class is called. This is usually overridden only in special cases. After this happens, the object is ready to be used. Other code can then interact with the object, calling functions on it and accessing its attributes. Eventually it will finish being used and can be destroyed. So before the object is brought into existence, the class has to be defined. When we need an instance of that class, we create an object, which stage corresponds to the init method of being called. That would be instantiation. When the object is destroyed, the memory allocated to it is freed up and can be used for other purposes. Destruction of an object occurs when its reference count reaches 0. Reference count is the number of variables and other elements that refer to an object. If nothing is referring to it, it has a reference count of 0. Nothing can interact with it, so it can be safely deleted. In some situations, 2 or more objects can be referred to by each other only, and therefore can be deleted as well. The delete statement, del, reduces the reference count of an object by 1, and this often leads to its deletion. The magic method for the del statement is underscore underscore del underscore underscore. The process of deleting objects when they are no longer needed is called garbage collection, which is a term that spans more than one programming language. So you'll hear about garbage collection in Java as well. In summary, an object's reference count increases when it is assigned a new name or placed in a container, list, tuple, or dictionary. The object's reference count decreases when it's deleted with del. Its reference is reassigned or its reference goes out of scope. When an object's reference count reaches 0, Python automatically deletes it, which is to say that Python has automatic garbage collection. There are languages that don't have automatic garbage collection, and this can lead to memory leaks, which means that variables or objects are created, but they are never deleted when they're no longer needed, and they consume progressively more memory, which can lead to memory overflow or just inefficient operation. So we've got A equals 42, B equals A, C equals A. So now this is increasing the reference count. If we delete A, decrease reference count of 42, B equals 100. We've reassigned it, so decrease reference count of 42, and then reset C index 0 to -1, decrease reference count of 42. Lower level languages like C don't have this kind of automatic memory management, which is why you have to do that manually, so to speak, to ensure that your program is not running inefficiently or going to consume excessive resources. What is del, the magic method for? Delete instance. And we're right about 45 minutes. Looks like we've got just a few left here, so we should be able to finish this up in the next lesson here. Data hiding, class and static methods, properties, a simple game, and then the module 7 quiz. So we'll be starting back up with data hiding in object-oriented programming. Then after that we'll move on to regular expressions, Pythonicness. Can't wait to figure out what that's about. And then we'll be on to finish up the course. Thanks again so much for everybody who tuned in. I appreciate you guys. As always, like, subscribe, recommend the channel. Comments, questions, critiques, requests are always welcome in the comments. So see y'all next time. Bye-bye.